Hi, everyone. My name is Walter Goulet, and I'm here to give a quick talk on stepping up your product management game with Python. I'd like to thank my old friend Ray here for inviting me to come in and talk. I am a senior product manager at Okta. I started my career long ago as a software engineer, but moved into consulting and product management. Oh my goodness, now that's like 7 years. I've got a background primarily in InfoSec, focused primarily on public key infrastructure, identity access management, privilege access management, which is why I'm at Okta. So what I wanted to do is kind of walk everybody through, like when you think about product managers, anybody who's an engineer, depending on your company, you probably have some level of interaction with product managers. And probably varying levels of degree of respect for product managers depending on your experience. But what exactly does a product manager do? How do we spend our time? Well, my job is really interesting because it's a mix of product strategy work, doing requirements analysis, market research, a lot of thinking about, well, what actually should we be doing? What's the best way to build products and services that provide the most value to my customers. And even if you're not a for-profit corporation and you're a product manager working in a nonprofit, you still are trying to figure out ways to optimize and bring value for your end users. And so this is a huge portion of what product managers do. And the way that you really kind of see that split, you might hear this sometimes when you talk to product managers, and depending on the size of the company, you might have two different people that have these roles. You have an outbound product manager. These are the type of PMs that are just talking to customers constantly, really understand the customer pain points, really got to be an expert on the pain. Not supposed to be an expert on exactly how things need to get built, but they really need to be experts understanding what customer problem we're trying to make go away. You also work with field teams, so sales people that are trying to sell your product or service, and then support teams. The other aspect of the product manager job is what we call inbound product management. And this is where we get to work with engineering partners, design partners, and other product managers. So for this kind of work, this is usually where you're spending most of your time communicating effectively with engineers, negotiating and figuring out what to build, working with designers, etc. So when you think about like what product management does and with those core tasks that I described, one key thing that's become more and more apparent to me as I progress in my career as a product manager is that data is the lifeblood of product management. And I think you can all sort of start seeing where the talk is going, the tie into Python. Because working with data that is going to be a mix of product usage data, customer data, log data from your product, sales information, the list goes on and on. A key part of our job is really understanding and figuring out how to harness a bunch of data that maybe is related, maybe not related, that needs to get kind of pulled together in order for us to really make data-driven decisions, figure out what's important to focus on or not. So thinking about as my job and what I do and how I've been effective at solving some of the data management problems for both outbound and inbound product management tasks, how has Python actually helped me? I wanted to just kind of walk through a couple of examples that I've experienced at work where I had to maybe solve some tricky problems. So the first one, analyzing large data sets. So at a company like Okta, we're a SaaS company, very mature. We process hundreds, millions and millions of authentication events and have many customers that use our products and services. And so that means that we have a lot of data to work with in order to help figure out trends, priorities, usage, et cetera. And trying to interpret large data sets is very difficult without some way of being able to automate, summarize in ways besides just spreadsheets. So Python, for me personally, being able to analyze and consume and process large data sets is something that Python is a great fit for. One key example that comes to mind is there was one scenario about a year ago where we were looking at some usage data and sales data, and the data was essentially split up into 38 spreadsheets that were just like all kind of loosely related. And in order for me to get the insight that I needed, I had to take 38 spreadsheets, combine them into one, and kind of join that data together in order to get the analysis that I need. And I very distinctly remember starting the process with just spreadsheets and then realizing by the third spreadsheet, there's got to be a better way. And that's when I was able to turn to Python. And in that case, I was using NumPy and pandas. And I realized, like, oh, wow, OK. Actually, if I take all those 38 spreadsheets and feed them into Python, I can actually summarize and get exactly what I need. So that allowed me to kind of turn around and provide real data-driven decisions to my management team, because we were able to look at the feature sets that we had built that were tied to the most revenue and usage. So one great example. Another one, generating reports. This one's, it sounds kind of boring sometimes, but reports are really key. Again, it's tied to being able to get insights that are actionable, and sometimes working with customers that need to get information that they need to understand about their own usage of the product. Examples I've had here are customers that maybe need to get some data out of our product but don't quite know how to generate it, or our APIs are something they can't really understand. Well, a product manager working with the PM can usually work with field teams and kind of guide them through generating their own reports to get usage data. And again, I've done this by helping customers by executing like Python, little small Python scripts. They're using the request library to generate and process data to provide reports to customers. The next one is one of my favorite ways that I've gotten a lot of value from Python. And again, I am talking as a Python person who's not an everyday expert like many of you might be that are writing production code, but just as kind of like more of a hobbyist, somebody who sits and is able to use Python more as a life skill to automate things. But I found that, especially for complex products like we build, where we have to interoperate with other product APIs and services, Python is incredible for me to be able to quickly kind of understand the shape, scope, how APIs work, and figure out ways that we can add value. So as a product manager, who's just trying to figure out how your product can interoperate with other products out of the world, understanding APIs, understanding how to work with your engineers to specify an API is so much easier when you can use tooling in Python to interoperate with those APIs. Because to the last bullet point, I have found that if you do this right and you understand how to work with APIs and be able to express ideas in code, that you can actually use this as a way to convey maybe more complex requirements to engineers, right? Just don't make a mistake I made earlier in my career where I tried writing something in Python, or maybe this was PowerShell back in the day, and handing it to engineers and saying, go build this. They don't like that. But if you say, you see this? This is kind of what I want. Maybe you can kind of interpret it. Then you're OK. So as long as you get that balance right, I found that Python can be very helpful as a tool in that. So just tying off with a couple of basic Python. This is very basic list, but I'm just calling out these three because I've been using them all the time. Requests, working with APIs is kind of built into Python, and there's obviously tons of modules that you can use for more complex interoperation with APIs. I should have probably listed the jot.io as well, because I've had to work with jot tokens a lot as part of my work. Pandas, again, I think with the data science angle, its ability to quickly enumerate, process large data sets, NumPy. These are just ones that I found I need to incorporate into some of those little scripts and tooling that I use. So hopefully this little brief talk maybe can inspire folks. Certainly you don't have to be an engineer or have a computer science degree to get value out of using Python for some normal day-to-day tasks. And I hope that hearing my story just maybe can inspire people that aren't necessarily engineers but have other roles in product development life cycle to turn to Python to maybe help them with their job. And that's pretty much it. I got to put up a couple minutes if there's any Q&A, and then I'll turn it over to the next speaker. All right. Thank you so much.
Anyone have any questions?
Yeah, hi.
Great talk, by the way.
Oh, awesome. Thank you.
Yeah, I was just wondering, with whatever software that you're using to manage your tickets, whether it's Jira, Atlassian Suite, or Shortcut, if you had any experience like scripting to automate ticket generation or reporting
Right. Actually, yeah, I have done that before. Because and both at Okta and at my previous job, very heavy Jira shop where sometimes you need to process a bunch of epics to process requirements, and I definitely have used it, not really for ticket generation, but more for the reporting angle. Like when we've got a bunch of stories that are worked on by 4 different Scrum teams and need to coordinate things, I've done some Python to basically download a bunch of data, Jira tickets, in order to generate reports before. But yeah, that's an interesting use case. Yeah.
So do you use, I'll say it loud, do you use Jupyter Notebooks for your development, or for
okay.
How do you prototype?
Right. That's a great question. So actually for me, I use VS Code actually. I think VS Code with its environment. I've been looking at notebooks, but more for my hobbyist stuff, not directly related to work. But for me, VS Code seems to be with the VI plugin, because I'm so old school. I can't even use a terminal window if I can't use VI. But I've played with Jupyter Notebooks, but I find that just using VS Code and then outputting the CSVs works for what I need.
You mentioned hobbies and side projects, so that begs the question, so what else outside from the work stuff?
Oh, yeah. Well, just some kind of toy stuff, with everything that's going on with advances in artificial intelligence. I've been trying to, I'm sorry, I forgot your name, but I was telling you my journey with Oracle machine learning, and we were saying, yeah, maybe that was the wrong one to start with. But they had free machine learning computing credits available, so I was actually using their machine learning library and pandas to work with some of the Oracle Autonomous Database instances, just to kind of learn a little bit about language, semantic analysis and some of those concepts, and a little bit of work with automation on Raspberry Pi and Arduino stuff as well. Cool.
You mentioned reporting in Python. Are you creating reports directly with Python, and if so, how does that work?
Yeah, so usually what I'm doing, it's funny because ultimately I need to take most of the time when I produce reports with Python, it's usually not like printed PDF style visual reports. It's more like trying to get a smaller CSV that I can it put somewhere else, right? So, usually for me, what I'm, a lot of CSV reader, writer, those libraries, and some of those to just, like that NumPy's example I was telling you about, I had the 38 spreadsheet report. I just had to take these 38 spreadsheets and then feed them in and do all the analysis to ultimately produce one small file that had all the key data I needed. But then that was just CSV that I fed into another master spreadsheet.
Right.
Cool. Well, thank you so much, guys. It was great to have the honor to talk to you for a few moments. Wow.
So I'm going to talk to you guys about tabletop role-playing games, like, you did. I do, yes. I'm going to talk to you about tabletop role-playing games like Dungeons and Dragons and Shadowrun and things like that. Do people, raise your hand if you've played a tabletop role-playing game before. Okay. So, wow, okay, like 60%. So some of this might be a recap for some of you. I have a long history, it's a horrible history with tabletop role-playing games. So in 2003, I went to some strange person's house and they were playing Shadowrun. And I was like, that seems weird. And then 2004, I played a session of D&D. It was terrible. It was really miserable. 2009, I started watching that Penny Arcade, you know, that TV show? Yeah. The reality TV show. It was really fun. It was actually genuinely like very sweet. And then they played at PAX. They did some live gameplay there, and I was like, oh, this is really cool. And then I worked at a company called Braintree. Used to host a bunch of events. And I put on a D&D night because I was like, I would like to play D&D again. So we got 30 people together for 40 people. And we had 6 different DMs all doing the same encounter. We were all in different parts of the office. And so everybody was playing the same game, and they would come back together and talk. It was really fun. And then in 2020, like March or February, I was like, oh, I'm going to start, I think what I want to do is be a dungeon master or a game master. I want to like help tell the story. So I'm going to get some friends together. We're going to play like 6 sessions in the year 2020. Well, spoiler alert, 2020 was weird. I don't know if you guys remember it. It was a weird year. And we played every week for a year. So I went from never playing twice in my life to being a dungeon master 52 times in a row. And then we played for a couple more years after that. Started the second campaign, and there's a Chicago meetup, really cool meetup at the Red Line VR. They do it also like 40, 50 people play on a night, the same event. It's really neat if you want to check it out. And this year it's kind of slowed down a little bit. So that's my history with it. And it's a story. I want to tell you a story. So here's me telling you a story. I don't have any connection to this particular avatar, but that's me. And so a story a story starts with a storyteller, I think. And so in this case, it's me. I'm telling you a story. You're listening to the story right now. You're the other half of this. You're the thing that I need. You are the audience of the story, right? And so if I'm going to tell you a story, I'm going to go like this for a while. I'm going to talk to you, and I'm going to try to get you excited about the story that I'm telling. It might be terribly boring, but my goal is to get you to be excited. And if I do that well, I might do it in different ways for different people, right? I might be swashbuckling. I recognize it in a heartbeat. Political intrigue, romance, maybe games of chance, right? Different concepts might come up in the story that I'm going to tell, and I'm going to engage you on that topic, right? And I'm not making it up. Like, I've prepared in advance. I've got this backlog of ideas and maybe settings and stories and events, people and natural disasters that might play into the story that I'm going to tell. And that's in a normal linear story that has a storyteller and has an audience like this one, like the one I'm telling you right now. This is a linear story, it has an audience. But those of you who have played tabletop role-playing games know how complicated such a story would be, right? So in a story you have things like character introduction, where you introduce a new person that the audience has never seen before. You have character action that takes place that shows you who that character is rather than tells you. You have dialogue that brings you into the story both as hearer and reader of that dialogue. So there's things that are being said that define the story, that change the way the story works. Artifact discovery. In that story, those people are acting and they're doing things, and suddenly they find an object or a book or something about the universe that they consume or they use, they expose themselves to, and it changes the story forever. And then events in the story that are bigger than all of that There might be something that happens to the people who are already on a moving train, and you can't expect that happens. And then you might just have exposition where we say, okay, at the end of the day, this is the truth, right? Here is some exposition I'm going to give you that says this story happens. So when I'm telling you this story, and I'm sharing a story with you, I'm going through all of these things constantly. I'm constantly introducing characters. I'm constantly showing you artifacts. And it's really hard to keep track of. And a linear story, it's not so bad. Let's go back to my example. Linear story, I can do that, right? But in a non-linear story, or in a story that isn't controlled by me, the one true storyteller, you have a different problem. So tabletop role-playing games, for those of you who know, you'll recognize this. All of the events come to the center of the table. They don't pass through me. They're put in the middle, and all of you interact about them, right? Something happens on the train. Well, what if when that knife got dropped, somebody said, oh, I immediately grab the person. The first thing I do is I hold on to them. That changes the story in a way that I can't control. Their characters might be introduced. They might change the world in a way that I can't predict. And so I lose control of that story. It makes it really hard to tell that story if you're trying to keep your hands on it. And so I think that's an interesting problem that you have in this kind of setting. But the cool thing is everybody's contributing. They're all adding to the storytelling process. And they're all building this one thing together. Not only that, everybody's taking notes. So they all get their little notebooks or their note cards, and they're all writing stuff down. How many people believe me in the tabletop? It's not everybody, it's one person in the group. It's writing down notes, right? So there's one person who's just like jotting down notes. And when you come back to tell that story the next week, at the end of your 52 weeks of COVID lockdown, and you're on story 52 and you say, you meet the guy that you saw 10 weeks ago, and his name is Jim, and they go, no, it's not Jim, it's Luther. You've forgotten his name. And oh shoot, how do I deal with that? So this storytelling is different in a way that it's collaborative, it grows, and you have to keep track of it in ways that you didn't have to expect. So, how do we deal with that? When you play the game, it looks like this, right? If you're a player in the game, you might see a dungeon master, in this case somebody like me, sitting behind that little wall, and you say, well, the keeping track of happens behind the wall. It must all happen behind that wall. That's where the story is kept. It's kept behind the wall. But the behind the wall looks a lot like this. This isn't my setup, it's somebody else's setup. I just didn't credit them. That's really rude of me. But you have some rules on the edges of that wall that you see. You might have some monsters or some things that you encounter in that story ready to go for this week's session. This week's, when you're telling the story this week, you might have that information ready to go. You have your dice ready to play the game, but it's all tactical, it's not strategic. Where in this do you see 50 pages about the history of the town that you're currently in, right? It's nowhere in this picture. It's not anywhere there. So where does it go? You've all seen this? Anybody have guesses where it goes? No guesses? Binders. It always goes in a binder. When I first went to go see that Shadowrun game in 2003, the person came out like with a tome. I have the game binder. I have the book. And it's got all the information that the group has done, and it's been tagged and tracked and all this stuff, and you keep it. You keep it forever. It's huge. You see how many 6 inches of paper you can have in a binder. And it's one vault. And it's owned by and you can't look at it. You can't look at the binder. It's my binder. It's my thing to keep. And I don't think that works out very well. And sometimes a binder might not be for you. It's certainly not for me. What I want is when I'm playing a game like this, I want to have an experience that everyone's playing the game and then we're all trying to remember what happened and we all remember the same thing. So they made these websites, these really cool websites. One on the left is called Obsidian Portal. The one on the right is called World Anvil. And I started to use both of these. Each one costs money. And I think they cost about $5 a month. And if you add to that the cost to play the game remotely and maybe you have a Zoom license, I don't know. You might have a lot of stuff. You start to use these things. You build like a wiki, right? Isn't it cool to have a wiki with all the things that you've learned along the way? That's pretty neat. They're really cool to check out. And you start to build a common place where your players can go to learn about, oh yeah, that chief of that group was connected to the princess or whatever. And I can go look up about it. In video games, it's a lot easier, right? This is from Death Stranding. the first ever strand type game. This is, it's neat, and so I love this game, by the way. Death Stranding is really fun. You could talk to me all day about why it's the worst game in the world. But one of the fun things it has is it's got so much lore. There's a lore drop every 10 seconds that just like blips up, and it's some long thing written and nobody understands what it is. But it's all this weird stuff about the future of the United States, and it's real odd. But you can always go back and you could read it. If you get lost, you're like, why am I doing this again? You can go read all these weird little articles. It's really fun. It's like, genuinely, I think it's really fun to go read this stuff. Learn about the time fall and bridge babies and all that stuff. And so what I want is something like this. I don't want that other, I want something that people connect to that's more exciting. If you look at these, you know, credit to the authors, it's hard to make software, but like on that page on the left, if that is, every wiki page looks like that. It's got one little button for wiki, and I got to click on everything, and I'll show you why I don't like it for other reasons later on. And on the right side, it's like there's so much space here for things I can't see. I want a fun experience, like I want to fill the screen with cool stuff and information. So here's what I built. Doesn't look like much because I'm not a graphic designer, but I will show you why it's cool in a little bit. But I'm going to explain to you what the sort of components are. It's called Secret Wiki. It's an open source project. It's on GitHub. You can check it out. It's written in Python and React and JavaScript. And it is designed to be a place where you can quickly edit shared information and where that secret binder, that tome, comes out into the open, but without giving all of the information away. Because it's hard to make something that can be like visible and shared, but also be private enough to keep a secret and keep a story interesting. So at the top you have a wiki. I have one wiki in this application, Scooby-Doo. This is the real, I wrote this as part of the preparation for this talk. This is the real breakdown of episode 1 of Scooby-Doo. What a night for a night. By the way, Scooby-Doo episodes, very simple. They're very simple things. On the left are all the pages, like a wiki, you might see. They're hierarchical. In the middle, you'll see the page that we're on. We're on the episode summary, or the episode intro, and we'll see the page title there. And we'll also see a section of information about the page title. So this is the first scene of the first episode of Scooby-Doo. And then you can dig in and see other things. So that's kind of what it looks like. There's also a search bar. There's some user interaction areas. And there's a place to create a page on the bottom left that I didn't highlight for some reason. But I'm going to explain just a couple things before we dig into this. I'll give you a demo, I promise. I swear I'll give you a demo. So this is just a C4 diagram made with Structurizer, and it kind of explains who is going to use this thing. So you have 3 personas that use the application. One is a player. So let's imagine that's you. That's all of you as like participants in this game we're about to play. There's the game master, that's me, the person who's going to read and write all of the information behind the scenes that you might not know. But you can contribute too. You can write your own sections. And then there's an admin. Doesn't really matter, but he can do some admin stuff. Or she, or they. And here's the data model. It's really simple. So we have wikis. Wikis contain pages. Pages might be subordinate to other pages. Pages contain sections. Sections are either secret or not secret. Similar to pages. Pages are either secret or not secret. But sections allow you to have overrides. So it might be a secret, but maybe you know it. Or maybe the 2 of you know it. Or maybe this half of the room knows it, but you don't know it, right? We can organize it that way. And then users are either game masters or they're not. So let's get into the demo, and I'll sit down for a little bit. See how responsive it is. Like I said, I'm not a designer. So one of the things you'll notice as we move through is it's really optimized for speed, right? Like you can move pretty quickly through all of the information in here, and I'm logged in as one of you all, as a user, just somebody without any privileged access. If you have a really good memory, you'll notice there are a few pages that are missing. The pages on the left, there are 2 characters that were not introduced yet. So here, for example, we see Mr. Wickles, the curator of the County Museum. Nothing weird about him. He's friendly and superstitious. We have some information about his appearance. Similarly, we have Scooby-Doo, aka Scoob. We have Velma Dinkley. We have Daphne Blake. If I want to, I can try to see any secrets that I might know. And I can click through. It doesn't look like I know any secrets. But let's say I'm playing the character of Fred, and I would like to write a secret. I can go into edit mode here, double click, and write a secret. Fred, anybody have a good secret about Fred?
He likes traps.
Oh, Fred likes traps. Some say he sets them. So right, we can create a secret, and I'm going to mark it as a secret here. And I am a person who has access to the secret. So there, boom, here's a secret. So if I log in as another user, that user won't see the secret. If I want to edit it, I double click again, boom, I'm in edit mode, right? It's designed to be as quick as possible. It's written markdown, you can do sort of whatever you think. You want to maybe link to, he has it out for, this is my favorite feature, ready? Open square bracket, S. Drops down, creates a hyperlink very quickly using a slightly customized markdown. Save it. Oh, is it going to do something weird now? Yeah. Demos, I tell you. All right. Well, we'll come back to that. I'll do it with the admin. One of my users reported an issue with this, and I think it might be related. But yeah, so you can save, you can create different secrets. You can see modify. This is one of those exact examples. You can delete things. You can move through the different examples. So I'm going to log out, and I'm going to log back in as the admin user. So the admin, you'll quickly notice, has some extra information. But let me show you, Daphne has a secret. So this might come up later in the story, in the experience, but Daphne's dad has on occasion put her in charge of the family arcade business. Something I didn't know about Daphne when I was reading about this. But it's a secret. It might come up. It might factor into the story somewhere. And then once it does, we can make it public. We can make it a public fact that everybody now knows about Daphne. So now that's available. If I log back in as the user, I would see it there. We also see the Black Knight. This is one of those pages that was marked as secret. That page is locked down. Nobody could see it except for the game master. And once I decide to, I can double click up here, get access to the slug, the parent of this, and I can decide whether it's going to be public now or not. Because they encounter the Black Knight. So now they want to see who the Black Knight is. They might not have all of the information about the Black Knight, like its personality and its identity. Oh my gosh, it was Mr. Wickles, one of 2 named NPCs in this episode. It had to either be Jameson Hyde-White or Mr. Wickles. Turns out it was Mr. Wickles. So not the guy who got kidnapped in scene 1. Big shocker from, again, Scooby-Doo. Yeah, that's it. It's kind of a simple way to keep track of this information. It's pretty much everything you've seen here is what it can support. It supports a little bit more for Markdown. But yeah, that's kind of it. Yeah, I'll continue with the demo unless somebody saw something, they're like, wait, what was that? Anybody see anything like that?
In the backend, what database are you using?
Oh, I love it. I love it. Let's get into it. So, the idea behind this whole thing is it should be fast, and hopefully you noticed that when we were working on it. It's fast locally, it's also fast remotely, and I'll show you some data on that. But one of the other keys is that the game master, I must be able to keep secrets from the players. Otherwise, why not just use this big binder where I can keep all that information to myself? I want to be able to share it with the players and have me have all of the information, but to have them have some of it. But they shouldn't be taunted by the fact that they don't know the information yet. They shouldn't be exposed or like, there's a secret here, you can't see it. It should be relatively easy to read through all the way through. And they should be marked clearly, that's why they show up in red. So you clearly understand you have a secret that you're keeping. Maybe you decide to make it public or not, but you know it's a secret when you look at it. So any player in the game could see that. So back to the architecture, again, we have those three players. We're gonna dig into the underlying details now. So those 3 players interact with different components. We just interacted with the React front end. Behind the scenes, there's a fast API app, and underneath there's a database running SQLite. And so it's a SQLite database, very straightforward. It makes it easy to do copies and to run 50, 75 copies without having to stand up any database infrastructure. And again, you're playing a game. It's not that important. So SQLite is totally fine. It's a great use case for this example. Inside, so that was a click into the application itself. I'm now going to click one level deeper into the fast API piece of this to give you some more information. This is an eye chart. I'll zoom in a second. But you can see the admin on the top, the React on the bottom. Let's zoom in a little bit. So the admin on the top uses this thing called Porter. It's a little custom library that is a CLI that allows you to import and export data. By the way, I see you craning, and I love your interest. There's a chair right here if you want to come up front. Yeah, right there. I hate to have people having to crane their necks. I appreciate it. So they would use the porter, the importer exporter on the top, and that would dump their data out to YAML, which they could then zip up and stick wherever they want to. I actually have a cron job that just copies the SQLite database out whenever there's a difference, and I'll show you that. On the bottom, the Fast API, this is kind of just a description of how Fast API works, but the React front end calls into the routing layer of Fast API, which calls the views. The routing layer is defined using schemas that say, like, if you get this kind of request, this is what you expect to see in it, then pass that information on to the views. Those views then use the models to interact with the SQLite database. It's a SQL Alchemy model system. So it's an MVC kind of layout. And then I have a test suite that runs and tests all of those components independently. So SQLite database under the covers, Python, Fast API, and React on the front end. Any questions about that so far?
Yeah. How are you locking the table? Like if multiple people are trying to edit the same thing, how do you handle it?
Well, so there'll be some built-in single thread for the access to SQLite, so it's pretty lightweight on that front. I haven't seen that much performance hit so far. We'll get into some performance stats. But yeah, the perks of using like the standard stuff for SQL Alchemy, it handles async pretty well. SQLite handles, the async SQLite library handles that pretty well. And we haven't run into any corruption issues yet, knock on wood, but 7 users per game, right? It's a little bit tough.
Well, but like let's say, they're both editing. Yeah, I get that you would have a single thread and everything, but like, they both go to save or something.
Right.
So the one who saves first, the guy who's still writing stuff.
Right.
Is his page updated before you click save?
No. So there's a lot of room for improvement here, but I think the way we try to tackle that is with version markers. So when you pull down your version, you get an auto-incremented version of that Goulet ID, and if that didn't match what was on the server, you'd have to reload that section and try again. I think there's some cool diffing stuff that you could do there too. But yeah, you have to do a page reload or switch pages to get the fresh sections each time. So it does, and that does create some issues around like fanning out sections, which by the way is incredibly difficult because I'm not a front end guy. So the Fast API, I'm going to dig into this part next. The Fast API provides you the Swagger documentation. If you guys haven't seen that, it's just like a common way, an interface to see all of your API information in the same kind of pattern. These are a bunch of routes. They're all pretty straightforward, right? List the wikis, search the wiki, list the pages, create a page, read a page, update a page, fan out a page. I didn't really include that in the talk, but it's like, how do you get the sections to split up? Because they need to be ordered, but how do you do that in a way that allows for creating a before and after? It's a little tough.
Is the markdown also allowing to build into that? Like if you do like a double count, will you get like, would that automatically create a subsection or?
No, within a section, you can put whatever markdown you want, but that is just a text blob in the database. And so you can have like a single pound header, like an H1 and an H2 and an H3, but it's all treated as one section. There's a philosophy about that, right? Like, so what I want is I don't want people to feel like they're seeing missing chunks of data. So I kind of want you to have a section per section. But sometimes I've done things like the history of a town, and the history is all one big block, and then I'll have another block that's the secret history of the same town, which might have the same 3 subsections, but it's just the next one down. So when I'm reading it, I'm like, yeah, you see, this is true, and this is true, and this is true, but you have to talk to the town drunk or something like that in order to find out the real history about the chapel on the hill, right? That kind of thing. So then you get your sections on a given page, create a section on a page, update a section with that section ID, delete the section, simple stuff, right? Let's dig into one of those. Let's dig into create a wiki page. So again, Swagger, great, right? Like it renders, this is all rendered for free once you use the schemas and the router definitions. I'll show you the code all the way down for this example. So we're just gonna focus on wiki create. But all I had to do is define a couple things, and I get all this stuff for free. So I get a little interface where it says, yeah, you need a wiki slug to make that URL. So the wiki slug would be like Scooby-Doo. That's the Scooby-Doo wiki. I could post the title, the slug, so like Fred might be an example of the title. Fred might be the slug. And Fred belongs to Mysteries Inc. So that's the parent page. And it's a secret? No, Fred's a well-known figure in the town of Coolsville. So Fred's not secret. And then the ID for the page, we just let the client generate a GUID. We use whatever GUID they want. Because there's no integrity concern there. And it gives you some examples of like what a successful result might look like. See on the right side. So this is the code you would use to get that interface. Like 15 lines. We can dig into pieces if we want, if people have questions about this specifically, but there's a couple of things I might want to call out. The response models on the top right, I'm returning a page type object. The page create is the thing that I'm expecting from you. I'm expecting a page create schema, so it's like a definition of that thing you just saw here on the left. I'm expecting that thing on the left, and I'm going to give you the thing on the right. They almost look identical, don't they? It's almost like they are. I'm going to use some plugins, like middleware stuff for Fast API to get me a database connection. So I'm going to get an async connection. By the way, this is my first async project. I'd never done Python async before. This was also my first Fast API project. I'd never done Fast API before. So this is about 2 years ago I started working on this. Wiki objects. So I can go look up the wiki based on the wiki slug. That's what that does. So it's like, go get me that wiki object based on the router, that wiki slug. And then I just want to make sure that there's an active user. So they're logged in right now. They can't submit a request without being logged in. I create a database, a nested database connection. This is a little weird, and like I think we've done some recent stuff at work that makes me think this could be significantly simplified. But I create a nested database connection. I create a page and I add it to the database. Close the connection. Return that page. So that's creating a page in the wiki. It's very straightforward. Here's a more complicated example I kind of threw in for free. Sections are tougher because the sections have permissions to them, right? I have to save the section, and then I have to go figure out what all the permissions are that are associated with the section. This again, probably some optimizations to do, but I create that section. I check to see if it's secret. If it's secret and you didn't specify the permissions with it, I'm going to tell you that you made a mistake. Otherwise, I'll just go ahead and add it, commit it. I'm going to grab it out of the database, async. Let me tell you, that brought me no end of pain, and I probably not the right way to do it, but I did it anyways. I set the permissions based on your thing, and then I add I update the section with the new permissions so that it has it. I grab the section back out of the database. You think, wow, that's a lot of database operations. I hope it's not slow. It's not. I write tests for all this code that I wrote. These are all the tests of the routes themselves. So you hear a bunch of examples. There's just tests. Tests that I can read a page, tests that I can't read an admin page, tests that an admin can read an admin page, tests that I can, all this stuff, the sort of tests that you would write. Here's an example, which is an example for the create page. I do a post using this client. I think it comes built in with, actually no, I had to do it because it's Fast API. I think it's an HTTPX client. It's just like request library. HTTPX is just async requests. I do a post with this thing. I should see that it's a 200 response from the server, meaning everything's okay. I should be able to pull the data out in a JSON format. I should be able to see that the ID is set. I don't care what the ID is. I should be able to see that it was my page. It is secret. That the wiki is set. That the page is everything's set correctly. And I should be able to, not only is the result from the server correct, but I can also reach into the database and make sure that the database object is correct too, right? It's a good test. So do we do it? Do we make that? I feel like it's pretty good, actually. And I didn't have this in mind when I built it, but when I was looking for examples, I'm like, I kind of want to build that. I think it's pretty close. But the way to build that isn't with Python. Python can't get you there. Because Python, all those like fun little double-click things, Python doesn't have a way to do that. There are some cool projects out there that are trying to get Python to run in the browser.
What about a Qt?
Right. You could set up a Qt. And I've done a bunch of Qt projects. You could build your own like local client application that lets you like have different widgets and bells and stuff. But the future is the web. And so I turned to our evil nemesis, I think of the two languages that are second best at everything, it's JavaScript and Python. I really do think. But JavaScript has got us beat here, folks, and we have to sort of exceed the high ground. So I do, at a Python meetup, want to talk to you about React and how I learned it. It's really, I know. It's really interesting. It's really fun, and it's actually pretty lightweight. Like once you get through some of the early hurdles. I got a friend who wrote a book on React, and he was very helpful in walking me through this stuff. But let's just focus. I'm going to tell you the story of the logout button, because the logout button is a really boring button. Nobody ever cares about the logout button, but I'm going to tell you about it. So React, the way it works is you have a function. The function returns JSX, it's called. JavaScript XML, I think. You return that object. So that's pretty much like HTML, except that you can put in programmatic things in braces, or brackets, braces. And so you'll see them throughout the code. You'll see props.logout, you'll see logout icon. Cool things like, oh man, I could just import a PNG, just stick it in there. That's neat. Like that's cool, it just works. Things like I can get a function and pass the JavaScript function to the onClick. That's pretty cool too. So when I click the button, it's gonna perform whatever's in that function. Yeah.
So I do notice that you're importing from a Unix file path. So is this running on the server side?
Yes. Yeah. Well, so you can do it two ways. The way that I showed you the demo is actually you compile it into JavaScript executables that would then get served up as static files from the Fast API. You can also run it as an NPM server. That's how I do it in production. I have a separate front-end server that serves up its own assets, but it's all client-side code. There's no server privileged access. It all gets rendered and evaluated.
So that's basically just telling you React, compile it, get the image, and then...
Exactly.
Okay.
And so when it builds its like resulting package, it knows where to put it. By the way, the one thing I did not learn is packaging stuff in JavaScript. It took me 2 weeks to figure out how to get this thing to run. And it runs, and if you want to look at the code, you can. But I can't tell you anything more about it. But the thing that's super common is that you get this props passed to you in your React component. And props is just a method, it's just a thing. But the way that JavaScript works, it's all just one big object with a bunch of stuff hanging off of it. So I have a logout hanging off the object, and that's being passed in. Props is passed in from above. So whenever that props changes, I change the logout button. That's it. Where does this get put? Where do we find that? One level up, I have a component called user actions. This has got a little bit of styling and formatting, right? It's got 3 different buttons. This is the top right of my page, right? It's got the edit mode toggle, the secret mode toggle, and the logout button. So we're up one level. We get the props just like before. And if you look down at the logout button, all we're doing, wait a second, we're just handing it the logout function from above, from the API thing. So all we did was just hand it down again. It's just trickle down functionomics here. I made that up on the fly. That's pretty good, right? So yeah, if you zoom in just a little bit, you can just see the user. Well, actually, why is that? Okay. I did not add a transition in here, but inside the main method, I've zoomed in on the part that matters to you, which is we have this user actions thing that we were just looking at, right? This is user actions. We're going to go to its definition. And so from here, we pass in props.api. Oh, well, that just came from somebody else's props. Well, this is silly. We just keep going up. And we get to the top, we get to the app. And the app, we hand in the API. But where does it come from? Aha, it comes from the API wrapper on top. And I've just passed that down 5 levels to get down to the bottom. So API wrapper is where our function lives, our logout function. Inside there, you see a logout function is defined. Aha, we found logout. Update JWT null. Well, that comes from somewhere else. But I see where logout is getting attached to that object. See, it hangs off the object. So logout is being defined there. It's being handed back there. This is a reference to a function. And back in my app code, you can see where I set up the JWT function, set JWT function. And this uses some React stuff, but state is basically like an agreement that like when this changes, reload the page, reload those components that are affecting it. And use cookies is just like, hey, store this thing on the cookies in the browser. That's it. That's how the logout function works. I create a function, I hand it all the way down. That function gets called when you click on it, and you kind of jump through some hoops. There's some other fun stuff in here, but that's an example of how to think about React stuff. And it gives you neat things like double-clicking on a area of the code. You made it. You got through the React code. Congratulations, Python Meetup. You survived. I think you should be proud. So that concludes the technical part of my talk for the most part. So the question is, should you use this amazing technology? The answer is, no, you should not. But I do. I use it, and here's some information about how I use it. There's a ton of information on here. I'll walk you through all of it. So I use it for 2 wikis. I'm trying to get the other DM to use it. He doesn't like some of the features, so he's waiting on me to implement some features before he adopts. We have 7 users. I have 159 pages. 32 of them are secret. I have 439 sections. 169 of those are secret. I have 633,000 characters. So for comparison, Lord of the Rings, about 2 million, 2.3, I think. But I don't think when they counted those, they included spaces, and I'm including spaces. So I think he still got me beat. Also, 55 file backups of like hourly and daily backups that I keep of the database. For comparison, Catcher in the Rye was 254 pages. So I'm not even beating Catcher in the Rye. That's a short book. 333 pages for Kill a Mockingbird, and almost 1,200 pages for the Lord of the Rings series, which is real high fantasy. But the local example I showed you, that demo, I ran through last night, and I said, well, what does the performance look like for the local mode, what we were just seeing, the demo? So initial connection overhead, that's like the time it takes to make a TCP connection, to get a connection to the server, 1 millisecond, because I'm local and it's HTTP. Super easy, right? If I try to do that on my remote deployed server, it takes 70 milliseconds. And if I try to do that against Obsidian Portal, my competitor, it takes 76 milliseconds, but it's the same. It's 6 milliseconds doesn't count for anything. If I want to load a page's sections, like when you click to load like between page, it takes 13 milliseconds locally. Again, less data in that example than in mine. Mine has all these pages, right? And I'm on the remote. So I got to go up to, I think Ohio is where it's deployed. I got to go to Ohio and say, give me the sections, and come back, and that takes 42 milliseconds. All right, 4 times as bad as local, but here's where we get to the good stuff. Saving a section, making a change like the changes you saw me make, takes 14 milliseconds on the local with SQLite, Fast API, React. It takes 61 milliseconds on the other one, and you're returned back to a state where you can move on with your life, 61 milliseconds. If you were to use Obsidian Portal, this is why I stopped using it. It takes 1,200 milliseconds to save, and you are entered back to a state where you have to then reload the edit page. So as a person who is writing a lot and changing pages and trying to write more, it would take somewhere between 2 and 3 seconds for me to make a change and then go back in and do another change. So you have to kind of do bulk changes in those systems. 2 to 3 seconds as compared to 61 milliseconds is crazy. And I love that. That's so cool. It's very fun to have made something that does that. Loading page content, which means like I do a refresh from scratch, 70 in the local, 260 on the remote. There's really no comparison because there's no page on Obsidian Portal that doesn't have content, so it doesn't really feel safe to compare. But their load page, another example, you can kind of see a steady climb on this, but here's the important thing. I'm almost never loading the page because I'm just moving between pages. So the actual number to compare is my 42 milliseconds against 425 milliseconds. That's a 10x improvement for most operations. That's pretty cool. Like, that's an optimization that I like. And then you see a couple other examples, page switches. How long does it take to open the edit page? Like just to open it. So if you add the 350 plus the 120, you get to like 1.5 seconds to just do an edit on Obsidian Portal. And if you're wondering, why do you have an ear and an eye on the lower side? Those are the times it takes for the human to do, on the left side, to observe something, and then on the right side to react based on visual and auditory input. So some of these times, even the low differences are noticeable to human eye. Like you'll feel the difference in the performance, and you'll react differently as you're using the software. They're within that window, definitely within the 1 second window, but like even like 425 to 42 milliseconds, that's a big improvement. And humans will notice that and feel it. So I use it, but I have as many broken bug reports and other things as I have pages in my wiki, so maybe it doesn't matter. Use World Anvil, use Obsidian Portal, use Google Docs, do whatever else, but if you ever want to come to my side of the, I'll take you. You can come, enjoy it. That's it, you've unlocked all the lore. Thank you so much. I really appreciate the opportunity to talk. Yeah, and I would take questions. Hey, good to see you.
Good to see you too. It's been a while. First of all, thanks for presenting and for hosting. My question's a little bit meta. You chose Fast API. I've not used Fast API. What can you say about it? And why should I use it, particularly in comparison to something like Flask?
Yeah, so Fast API is opinionated in a way that I enjoy. I liked kind of working in Rails, which kind of made me like Django a little bit. And then I never made the jump to DRF, Django REST framework. But Fast API sort of started in the post data typing definitions, post Python typing world, unlike Django and unlike Flask. And so when Fast API started, like I think Pydantic was already on the scene. And so they're like, oh, cool. So we have Python data types, and we have this framework for serializing and deserializing data using those common definitions. What if we just use that to describe our API and take advantage of what other languages are getting for free out of their type definitions? And so that's really cool. And I know that might sound kind of like highfalutin and whatever, but I can take a class and go email : email string from Pydantic, name : string. And like that, I have automatic validations built in for email types, for name types, for list types, or I could have complex nested objects. And Fast API does it for free and builds me that nice JSON, that Swagger spec. And so I can get that Swagger spec, everything up and running in less than 5 minutes for the first route. And that's cool. That's like super fun for me. Then on top of that, I think just like they're moving toward async first, which I didn't love. Somebody who started sync first. But starting async first, I think, has some advantages, and sort of starts you in this mode of like, this is where you should start operating, write your code this way, and you get some really cool performance benefits. I think Fast API, you start to see some of that, like anywhere from 3 to 14 millisecond response times is pretty solid. And I think Flask isn't that far behind it, but it's a fair bit. And once you start scaling up, it gets pretty slow. Django much more. So yeah, but that's why. But like, they're all good. Use them all. Yeah.
So I'm just curious about your database async stuff. So I think SQL Alchemy 2 does async.
Yes.
But like, I don't know if you're using 2 or 1, but either way, like, what kind of issues did you run into when doing database stuff?
It was horrible, because I started with the sync thing, and I was just like, okay, I'm going to do this, and then I can't remember what it was. I wanted some feature. Oh, it was, I wanted to use the built-in JWT stuff with Fast API users. They have built-in JOT validation that I was like, oh, cool. I can just have this library take care of all this stuff. And then just before I was about to install it, they're like, we're going async only. So you had to switch your application over to be async. So I had to do like a rewrite midstream. It wound up stopping my development for like a month and a half. Because I tried it once, I'm like, oh, this sucks. And I came back. I still don't fully understand how a developer is supposed to interact with the async database model, especially SQLite, which is kind of like, I think you well pointed out, like locking issues, like it's shady. SQLite is like, it's very impressive. Some companies, there are lots of companies that just use it for scale because you could just make 1 million databases, like who cares? But I am still spooked by it. And I truly can't answer all the questions, but like making sure you are loading an object from the database and then you are operating on it with the same database session was a huge problem. So that's where you see me reloading objects. I have an example here. There. So you'll notice the 4th to the last line, or 5th to the last line, is it's a really silly thing. I'm like refreshing out of the database this section, just so that I can write it back. I just created it, just not moments before. But because I had to do this nested, I wanted to like commit the session so that it was stored in the database. The async with, there were issues I was running into where the async with would have to close because I was trying to commit before doing the next operation. And then I would start another session and it would say, you can't touch that object. That object came from somebody else. I'm not touching it. And so that drove me up the wall. And I don't have a right answer for you yet. I haven't done enough async, like, especially with SQLite. But hopefully that kind of answers some of that.
Do you recommend SQL Alchemy for still, like, or?
Oh yeah, yeah. We have a couple. Work at a company called Spot On, and the company is largely Fast API and Go, and we actually use the databases module, which comes, it's like alongside Pydantic. It's like produced by the same people, and that one's kind of okay. It's really, really abstract, and it's actually really nice. Like if you're doing a simple database thing, check out the databases module. It's super great for async. But it seems like the SQL, it stops short in a couple areas like enums and things like that. So if you want to do something more complicated, I would say the SQL Alchemy, and I've had no issues with that here.